This is Unit 4, Linear Equations and Linear Systems, Lesson 12, Systems of Equations, and this is Activity 1, called Milkshakes. And in this activity, you have two students, Diego and Lynn. They're drinking milkshakes. Lynn starts out with 12 ounces of milkshake, and drinks 1/4 of an ounce per second. So every second she drinks 1/4 of an ounce. So this 12 ounces, we're going to graph this, or actually you're supposed to explain the graph without graphing it. And so this 12 ounces is where she starts. So at time 0, she has 12 ounces. So this is the y-intercept. And she drinks at a rate of 1/4 of an ounce per second. That's the rate, or the slope. That's how much she's drinking every second. And that is a negative 1/4 of an ounce per second, because the milkshake is leaving, it's going away, she's using it up. So when it all gets used up, that's the amount of time that it takes to drink that entire milkshake. So this 1/4 of an ounce is removed, it is negative. Diego, on the other hand, starts with 20 ounces, so that's his y-intercept. When time is 0, he has 20 ounces of milkshake. He drinks 2/3 of an ounce every second. So this 2/3 of an ounce is negative. So his slope, his rate is a negative 2/3 ounces per second. So it's a negative rate or slope. Now notice when you look at this, Lynn has fewer ounces, but she's drinking her drink a lot slower. So 1/4 of an ounce per second than Diego. Diego starts out with more, 20 ounces, and he drinks it very much faster, so 2/3 of an ounce per second. And you're going to find out that Diego actually finishes his drink before Lynn finishes her drink. So what that means is that at some point in time, Diego will have fewer ounces than Lynn. Starts out with more ounces and ends up with fewer ounces than Lynn. That means at one point in time, they will have the same amount of milkshake. Their graphs will intersect, they will cross. So look for that as we go through this. So if this is Lynn's drink, so this is a division problem. Lynn drinks 1/4 of an ounce for every second. So she has 12 ounces. So how many of those 1/4 ounces are in her 12-ounce milkshake? That's the number of seconds. So if this rectangle represents 1 ounce, then 1/4 of an ounce is this red square right here. So how many 1/4 ounces are there in 1 ounce? There are 4 of them, because 4 times 1/4 of an ounce is equal to that 1 ounce. But she has 12 ounces. So if there are 4 1/4 ounces in 1 ounce, then 12 times that means there's 48 1/4 ounces in her 12-ounce drink. Well, every 1/4 of an ounce is 1 second, so that means that she takes 48 seconds to drink her milkshake. So let's go through that mathematically, where we do the calculation. So that's 12 divided by 1/4. You're answering the question of how many of these 1/4 are in 12 ounces. So imagine that you have 12 of these rectangles. How many of these small squares are in a total of those 12 rectangles? Well, that's 12 divided by 1/4. And to solve that problem, to solve a division problem, you can use the inverse operation, which is multiplication, and the multiplicative inverse of 1/4 is 4/1, or 4. That is also called the reciprocal. Well, 12 times 4, there's that 48 right there. So it's 4 1/4 ounces for 1 ounce, and then it's 12 times that. So 12 times 4 is equal to 48 ounces. Another way to look at that calculation is 12 divided by 1/4. You can multiply the denominator by the multiplicative inverse, or the reciprocal. That changes this denominator to 1. You have to do the same thing to the numerator. So 12 times 4/1, there's that 12 times 4 right there. And that 12 times 4 is same here, equals 48. Now Diego is a little bit tougher because it's a little bit harder to see the fraction 2/3 and how many of those 2/3 are in his 20 ounces. That's the division problem, 20 divided by 2/3. Once you know how many 2/3 there are in 20 ounces, that's the answer. That's how many 2/3 ounces there are, that's how many seconds it takes him to drink that drink. Well, in 2 ounces, so if this is 1 ounce, then this is 2 ounces. In 2 ounces, there's 1/2 of an ounce. I'm going to use this oval here to mark the 2/3. There's a second 2/3, so a second oval right here. And I'm going to mark this 2/3 as that same circular dot right here. So how many 2/3 ounces are in 2 ounces? There's 3 of them. 1, 2, 3. So 3 times 2/3 ounces is equal to actually those 2 ounces. So there's 3 2/3 ounces in 2 ounces, or 3 times 2/3. 1, 2, 3. 3 times that 2/3 equals the 2 ounces. Well, 2 ounces is 1/10 of the total amount of 20 ounces. So multiply 2 ounces times 10. That means you multiply this 3. There's 3 of the 2/3 ounces in 2 ounces. So how many of these 2/3 ounces are in 20 ounces? It's 10 times that. So there's 30. 3, that 3 right there times 10 is 30 2/3 ounces in 20 ounces. So that 30 2/3 ounces is 30 seconds. So it takes Diego 30 seconds to drink his drink. So he drinks his drink faster than Lynn drinks her drink. She takes 48 seconds. So the math can look like this: 28 divided by 2/3. So to solve that, you're going to use the inverse operation, which is multiplication, and you're going to use the multiplicative inverse of 2/3, which is 3/2. So here's the 20 divided by 2 right here. That's 10. 20 divided by 2 is 10 times this 3. So it's this 10 times that 3. This 10 times the same 3 actually equals 30 seconds. Another way to look at that calculation is write it as a fraction, 20 divided by 2/3. To get rid of this denominator, multiply by the multiplicative inverse, or times 3/2. Do the same thing in the numerator. So again, we have the 20 times 3/2 over 1, or 20 times 3/2, which is right here. Same 20 times 3/2. So this is going to equal 30 as well. 20 divided by 2 is 10. 10 times 3 is 30. All right, so what does the graph then look like? So you're supposed to put together a description of the graph. So let's begin with Lynn's 12 ounces at 1/4 of an ounce per second. Takes her 48 seconds. Diego, 20 ounces at 2/3 of an ounce per second. Takes him 30 seconds. So he drinks a larger amount faster than Lynn drinks a smaller amount slower. So just the beginning graph here, this is 1 ounce. So this is 1 ounce right here. And this is 1/4 of an ounce in 1 second. So she drinks 1/4 of an ounce in 1 second. So how much is she going to drink? Oh, actually, let's look at it. Diego now, he drinks 2/3 of an ounce in that same 1 second. So here's the same 1 second, but he's drank 2/3 of an ounce, much more than what Lynn drank. She only drank 1/4 of an ounce in that 1 second. So 1/4 of an ounce per second, that is the same as it takes her 4 seconds to drink this whole 1 ounce. So 1 second, 2 seconds, 3 seconds, 4 seconds, or this is going to intersect down here at 4 seconds. But I want you to see is if you have a ratio written as 1/4 of an ounce per second, or a rate, if you take the reciprocal of that, this is 4 over 1, then it becomes 4 seconds for 1 ounce. So this is 1/4 of an ounce per second. This is seconds per ounce. Same thing here. This is 2/3 of an ounce per second. So in this 1 second, he drinks 2/3 of an ounce. Well, how long does it take him to drink 1 whole ounce to get down to the bottom here? Well, you can see it's going to be 3/2 seconds. This is 1 second, and so this is half of a second, and this is half of a second. So it's going to be 3/2 seconds. So it's going to intersect right here at 1.5 or 3/2. So notice once again, if you write the ratio as 2/3 of an ounce per second, then seconds per ounce is the reciprocal, 3/2 seconds. So 3/2 seconds right here per 1 ounce. This whole ounce will be drank in 3/2 seconds. All right, so let's look at the whole graph. So this is Diego. He starts out with 20 ounces. So no time. He hasn't drank any of his milkshake. So it's 0 time. He has 20 ounces. He drinks 2/3 of an ounce per second. So how long is it going to take him? It's going to take him 30 seconds is what we figured out to drink all of that 20 ounces. So when he has 0 volume left, all that 20 ounces is gone, it will have taken him these 30 seconds. So this is his graph right here. Lynn's graph, let's actually fill this in a little bit. So 2 ounces in 3 seconds, or 2/3 of an ounce per second. So just different ways to write that relationship. So think about that. 2 ounces in 3 seconds. So this is 3 seconds right here. And he drank 2 ounces. This is 20, 19, 18. Took 3 seconds, or it's the same as 2/3 of an ounce in 1 second. So you go back here to 1 second. We're going to do that in a little while. You see that he drank 2/3 of an ounce right there in that 1 second. A little bit hard to see. So Lynn starts out at 12 ounces, and she drinks all of her milkshake in 48 seconds. So when there's 0 time, she has 12 ounces. When all that milkshake is drank by Lynn, it will have taken her 48 seconds. So she has 0 volume at 48 seconds. So this is her graph. So again, the same idea, 1 ounce in 4 seconds. So this is 1 ounce, and this is 4 seconds. This is 2 seconds. This is 4 seconds. So 1 ounce in 4 seconds is the same as 1/4 of an ounce per 1 second. So if I go to 1 second, which is right here, and again, we're going to look at this closer in a moment, you'll see that that's 1/4 of an ounce right there. All right, let's look at the equation. They don't really ask you to do that, but we should do that anyway. This is the direction we're going. So let's go back to the original form of the slope y-intercept form of the equation, or slope-intercept form. The slope for Diego is a negative 2/3 ounces per second. So times each second. So x is the number of seconds. So he drinks a negative 2/3 ounces for each second. Remember, he starts at 20. So this is the slope, negative 2/3, and this is the y-intercept, 20. Lynn, same form of the equation, y equals mx plus b, but her slope is a negative 1/4. And where does she start? She started at 12 ounces. So her y-intercept is 12 ounces. So you can use this information. This is Diego, this is Lynn. You can actually use this information now to figure out at what point in time do they have the same amount of milkshake. There's going to be one point in time where they have the same amount of milkshake, because Diego has more, but he's drinking his faster. So down here, he has less as he finishes. And he finishes before Lynn. So at this point right here, he catches, you can view this as catching Lynn in terms of where they have the same amount of milkshake left. So he's drinking more and more and more and more. She's drinking less at a slower rate. And so he catches her. They have the same amount. And then he finishes faster than she finishes hers. So what's this point right here? Well, that's the amount. It says ounces of milkshake. So that's y. And that's the same for both of their equations. So a negative 2/3 x plus 20, negative 2/3 x plus 20, and a negative 1/4 x plus 12, negative 1/4 x plus 12. You make those equal to each other, and you solve for x. What's the value of x when these two equations are equal to each other? You can add 2/3 x to both sides. So this is plus 2/3 x. this goes away, and you can add a negative 12 to both sides. So this 12 goes away, and this is 20 plus negative 12. You end up with 8/12 x. You change both of these to 12ths because you're going to add them together, or you're going to add the positive to the negative. You end up with 8/12 x plus a negative 3/12 x. So this is 8/12. This is a negative 3/12, and they both equal together, they equal 8. So 20 plus negative 12 is 8. So you end up with 5/12 x equals 8. And multiply by the multiplicative inverse of 5/12. Actually, you're dividing by 5/12. So you're going to multiply by 12/5. That's 96/5. So you should go through these calculations and make sure you understand where these numbers are coming from. 96/5 is the same as 19 1/5. So think about that for a moment. 100/5 is 20. There's 20 nickels in a dollar. So 100 divided by 5 is 20, but this is 95 divided by 5 is 19. So this is 1/5 more. 96 is 1/5 more than 19. So this is 19 1/5, same as 19 2/10. So this answer right here, how long or at what point in time do they have the same amount of milkshake in their drinks? That is at 19 2/10 seconds. Now we haven't calculated y yet. You might want to figure out how many ounces is that in their milkshakes at this time of 19 2/10 seconds. How much do they have in their milkshake when they have the same amount? So you can take either one of these equations. I took the negative 1/4 x plus 12. Replace x with that 19 1/5 right here. Remember that 19 1/5 is the same as 96/5. So once you've done this calculation, you don't have to redo it. It's right here. A little bit hard to see that a negative 1/4 of 96/5 is 96/20. So think of 1/4 of 1/5. 1/4 of 1/5. 1/5 is the same as 4/20. So 1/4 of 4/20 is 1/20. So 1/4 of 90. 1/4 of 1/5 is 1/20. 1/4 of 96/5 is 96/20. But go back to here and think about 1/5 is the same as 4/20. So 1/4 of 4/20 is 1/20. So 1/4 of 1/5 is 1/20. So 1/4 of 96/5 is 96/20. So these are smaller pieces. Plus 12, a little bit hard. You have to practice what multiplying by fractions means. So 96/20 plus 12. This is a negative 96/20. And so 96/20, well, 4 times 20 is 80. So this is 4. You have 16/20 left over. 80, 90 plus 6 more is 16. So this is a negative 4 16/20. 12 plus a negative 4 is 8, which is right here. And 8 plus a negative 4/5. So what you have is this negative 4/5 left. 8 plus a negative 4/5 is 7 1/5. A little bit hard to kind of go through this. Just trying to give you some ideas of where those numbers come from. So this answer right here is 7 2/10 or 7 1/5, same amount. So when they have 7 1/5 ounces of milkshake, they both have that same amount, and that happens after 19 1/5 seconds. Now another way to figure out this 19 1/5 seconds is to look at this gap here and figure out how many seconds does this gap close to get to where there's no gap. So you're starting out with an 8-second gap. 20 minus 12 is 8. And how much does this close each second? And then it's that 8 divided by that amount. So let's zoom in on this. Let's look at 1 second. I'm going to figure out how much this gap closes in 1 second. So remember, this is 2/3. This gap closes by 2/3 of a second as Diego drinks his drink. So every second the gap closes by 2/3. But notice that when Lynn drinks her drink, the gap widens by 1/4 of a second. So we've gone through this before, and a little bit hard to see. But once you get used to reasoning through these problems in this way, you can check what's going on. Does it make sense? So this gets wider by 1/4 of a second. This gets, or 1/4 of an ounce. This gets closer by 2/3 of an ounce. So that difference is 2/3 minus that 1/4. So remember, this is a negative 2/3 ounce per second. This is a negative 1/4 ounce per second. But I'm going to just work with them as positives right now because I just want to know how much this is closing. It's closing by this 2/3 minus 1/4. Why is it minus 1/4? Because you have to take this portion away from this amount that it got closer together. So this inched farther apart. This got closer together. So 2/3 minus 1/4 is the same as 8/12 minus 3/12 equals 5/12. Well, we saw that when we figured out the equation. It's right here. This is the 8/12 right here minus 3/12 right here, and that equaled 5/12 right here. So the reason I'm doing this, looking at this gap, is you can see where the calculation comes from. So it's 8/12 minus 3/12 equals 5/12. So how many of these 5/12 are in 8 ounces? That's that 8 divided by 5/12. 8 divided by 5/12. We saw this before. Right here. 8 divided by this 5/12 is the same as 8 times 12/5. Multiply by the multiplicative inverse of 5/12, which is 12/5. 8 times 12/5, that's the 96/5. That equals 19 1/5, or 19 2/10 seconds. So this is hard to think about in the beginning, but once you start looking at problems in this way, you can see, you can visualize where this calculation is coming from. And it begins to make more sense to you. The whole idea is to make sense of these problems rather than try to memorize how they do them. Just make sense of it, and you will be able to work it out.